Alright guys, today we're finally going to get into proofs a little bit, and proofs are kind of challenging, but if you remember all of your different properties, it tends to go a lot easier. And today, algebraic proof, you've shown how to solve problems in algebraic form for a very long time, but you haven't necessarily thought about how to go ahead and prove what you're saying is true by providing a justification. So that's what we're going to be doing today. Okay? So basically we're going to be solving some equations, and you're going to give me a reason for each step. And some of these just take practice. Okay. So we're given, solve the equation 4m minus 8 equals negative 12. Okay, so we have 4m minus 8 equals negative 12. And the first step that you always do in your proof is usually going to be a given. Okay, information that you were given, you didn't do anything. Okay, so 4m minus 8 equals negative 12. That's just given to you. Okay, now of course to solve that equation, you would want to go ahead and add 8 to both sides. Okay, but why do you do that? Why do you go ahead and add 8? What rule says you can do that? Okay, what that rule is called is the addition property. The addition property of equality. The addition property of equality. Okay, so make sure you remember that one, addition property of equality. Now you can go ahead and reduce 4m equals negative 4. And whenever you reduce in these algebraic proofs, the reason is always just going to be simplify. Okay, you're just simplifying it, reducing it, making it look a little bit more simple. Okay, last step in solving the equation. Of course, you're going to divide by 4. Okay, but the reasoning for that is by the rule called the division property of equality. The division property of equality. Okay, so make sure you have that down. And of course, the last step, we're just going to go ahead and solve it out. M equals negative 1. And like we talked about before, whenever you're simplifying, you just put simplify. Okay. So these take some practice, but we're going to get through it. You're going to learn a lot of these different properties, and eventually you'll be more comfortable with them. Okay, so let's try a couple more of these. Alright. Okay, so it says solve the equation 1/2 t equals minus 7. Well, remember, you have to go ahead and write down your problem. Okay, and when you're given that, of course, your step is just going to be given. It was given to you, you didn't have to do anything. Okay? Now to solve that equation, 1/2 times t, so you want to undo multiplication with division, so you're just going to divide each side by 1/2. Okay, and the reason you can divide, of course, just like the one up top, you're using the division property of equality. Division property of equality helps us solve that one. And if you go ahead and solve, those 1/2s cancel, so you have t remaining on the left. And if you divide negative 7 by 1/2, you're going to get negative 14. And our reasoning is going to be, of course, simplify. Okay, so these really aren't that bad as long as you know your properties, and we will get to know those like I said before. All right. Okay, so you'll notice you're going to have problems that we've used before, but now you're just kind of adding in some justifications for how you took each step to solve that problem. Okay, so let's look at this. We want to find what x is. Okay, so it says solve for x. That's what we're going to do. Okay, so if we wanted to write an equation to solve this, we of course could write 2x plus 3x minus 9 equals 4x minus 4. Okay, and basically that's saying this segment plus this segment equals the whole segment. And what is that called when we do that? That, of course, remember, is called the segment addition postulate. Okay, so when you add two segments to equal the whole, that's called the segment addition postulate. Okay, so let's keep going here. Well, what can we do? Let's see. On the left side, we can put some stuff together. 2x plus 3x gives us 5x minus 9 equals 4x minus 4. And why can we do that? Well, the reasoning, of course, when you combine like terms, is you're combining like terms. It's as simple as that. Okay, now we got variables on both sides equation, and we can go ahead and go through here and solve. So let's subtract our 4x on both sides. Okay, but why can we do that? When we subtract 4x on both sides, you're going to be using the subtraction property of equality. Okay, so when you subtract on both sides, you're doing addition with subtraction using the subtraction property of equality. And if we go ahead and reduce, you'd have x minus 9 equals negative 4. And our reasoning for that, of course, is going to be to simplify. Okay, one more step. You need to go ahead and undo subtraction with addition. Add 9 on both sides. And to do that, math allows you to do that because of the addition property of equality. And of course, if you go ahead and reduce and simplify, you get x equals 5, and we can do that because of your simplification. Okay, so these problems aren't that hard. You just have to take your time and try to understand what's going on at each step along the way. All right. Okay, so we did the segment addition postulate. So now we got one for the angle addition postulate over here. Okay, so let's do one for that. All right, so we want to solve for x again, and I apologize that it doesn't say that on the instructions. Okay, so over here it says the whole angle is 8x, and we know that each of these little angles are 3x plus 5 and 6x plus 16. Okay, so we know the angle addition postulate says that two angles added up equal the whole angle. So we have 3x plus 5 plus 6x minus 16 equals the whole angle 8x. Okay? And we know we can do that because of the angle addition postulate. I'm just going to kind of abbreviate that for you. Okay, we know we can set up that equation because of the angle addition postulate. Okay, so let's go ahead and start solving. Okay, we can combine like terms on the left side and give us 9x, 3x plus 6x is 9x, and 5 minus 16 would give us negative 11. Okay, so once we go ahead and reduce, you're doing that because of your combining like terms and simplifying. So combine like terms and simplify. All right, let's go ahead and finish this thing up. Okay, you subtract 9x on both sides. And you can do that. Why? Well, of course, you can do it because you're using the subtraction property of equality. Subtract 9x on both sides because you're using the subtraction property of equality. And then if we go ahead and reduce, we can do that because we're simplifying. One more step. Okay, so we want to get x by itself, so of course you're going to have to divide by negative 1. And that property is simply called the division property of equality. Okay, I'm not trying to trick you. These are fairly straightforward. Okay, you just got to take each step slow. And then, of course, finally, if you solve it out, x would equal 11. And that reason would be your simplifying. Okay, so these problems are exactly what you have done before in past units. And now you're just kind of giving a step for each one. Okay? All right. A couple things for you to write down, and then we'll be done. What I want you to remember, and write this down, numbers are always equal. Okay, so numbers are always equal. Okay, and figures, like a line or a segment, are always going to be congruent. And I'm not sure what this symbol is. You're going to use this symbol for congruent. Okay, so we want to go ahead and identify the property that justifies each statement, and we're going to make a little foldable later on that kind of talks about each of these different properties. Okay, so it says angle QRS is a congruent to angle QRS. Whenever you have something that's congruent to itself, you're always going to be using the reflexive property. Okay, the reflexive property of congruence. Okay, the reflexive property of congruence whenever something's equal to itself. Okay, letter B, it says measure angle 1 equals measure angle 2. So measure angle 2 equals measure angle 1. Whenever you have that situation, it's always going to be called the symmetric property of equality. Okay, so the symmetric property of equality. Two more. C says AB is congruent to CD and CD is congruent to EF, so AB is congruent to EF. And this is kind of like our law of syllogism that we learned last time, okay, but in this situation, it's called the transitive property of congruence. Okay, and then once again, I will spend some more time on this. Okay, and last one, 32 degrees equals 32 degrees. Well, it's just something that's equal to itself. So once again, we have the reflexive property of equality. Okay, so reflexive property. Okay, so you'll notice on each of these, some of them are congruent, some of them are equal signs. Okay, so remember, numbers are equal and figures are congruent. Okay, so be aware of that. Okay, before you get started on your homework, I would like you to look through these 4 examples real quick and make sure or decide which type of property they are. All right, see you.